Summary for one-dimensional motion. One-dimensional motion involves these different properties: position, displacement, velocity, acceleration. And the motion, one-dimensional motion, have two different types. We call two models. Models are simplified types of motion. And these vary two different types. One is with constant velocity and the other is with constant acceleration. It's important to apply the correct model. We're going to demonstrate that with examples. So first of all, these are four different properties we introduced. Okay, if it's the unit is meters per second, that has to be velocity, can't be displacement. If the unit is meters per second square, it must be acceleration, it can't be velocity. This is how we can read between the lines and use the units as a hint. Displacement is in the unit of meters, so is position. And so displacement can be negative or positive, and velocity can be negative or positive. Acceleration can be negative or positive. So these are the four different quantities. And here are definitions of average velocity and average acceleration on the right column. Okay, I'm gonna use a laser pointer for this. So two-dimensional, two models for the one-dimensional motions. On the left, so here we have three different properties to characterize what's the constant motion with constant velocity, okay? So this velocity, this v, is a constant in the duration of the motion, which means it doesn't change. If it's 25 miles per hour, it's 25 miles per hour for a period of time. So on the right-hand side, these are constant accelerations, motion with constant acceleration. The initial velocity is v0 and it accelerates uniformly until in the end it becomes v. What doesn't change is the acceleration. Acceleration remains a constant in this special type of motion that's called motion with constant acceleration. Let's see, for these different this group of quantities, how are they related? And for this group of quantities, how are they related? So in physics, we study how different properties are related. On the left, we see this is how the quantities are related. Can we apply that to the right-hand side motion? Put that here, yes or no? No, 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 because that's not correct. This v is not a constant because the velocity goes from v0 to final v. So we can. Instead, there are four different equations that characterize the relationship among these different quantities. Each one represents the relationship among four different quantities. So there are five of them. So look at the first one that has everything except, can you see? Acceleration. The second one has everything except every five properties except displacement delta x. The third one has five properties except, which one is not in this one? This one seems like has a lot, right? There is one quantity that's not in this, that's the final velocity v. And look at the last one, has initial final velocity, acceleration, and displacement, which is the property of the five that's not in the last one, time. So by selecting the correct equation, you can solve different problems. Okay, I'm going to use three different problems to demonstrate problem-solving strategies. Number one, one-dimensional motion with a constant acceleration. A car is traveling at 11.17 meters per second. So that's the initial velocity. v0 equals to 11.17 meters per second. How do I know it's velocity? Because meters per second represent the property velocity, so that can only be velocity. How do I know it's initial? Well, to be honest, I've read this problem 100 times, so I know. When you solve a problem, right, when you see it the first time, you may not know its initial velocity. What you do is you read, and read. So when you read, you're gonna gradually pick out these information and match them with the model you know. A car is traveling at 11.17 meters per second, so that's a velocity, right? brake uniformly means changing the velocity uniformly. That means it's a constant acceleration motion. So that tells us the type of motion. Stopped means the final velocity is 0. 2.0 seconds. How do I know that's time? Because time, seconds is the unit for time. So that can only be time. It cannot be velocity. How far did it travel? How far translates into displacement? Okay, so that's how I analyze this problem. Basically, I translate words into mathematical expressions. Nobody can translate it by reading at once. If you try to do that, you might miss a lot of important information. So the rule is, it's not a rule, but this is my recommendation for you. Read, and then what? Read. Yes, you got it. And just remember to use that every time you solve a problem, at least 3 times. It's okay to read 4 or 5 times. Okay. Apply an equation. Why do I select this equation instead of the other ones? There are 3 known quantities and 1 unknown quantity. This is the only equation that has the 3 known quantities and the 1 unknown quantity. So this one happens to work. If you started by trying another equation, then you're going to realize that's not going to bring you from the 3 known to the unknown. So this is the one we pick. And if we plug in the numbers and solve it, this is the result. In summary, in this problem, we learned how to analyze a problem. That is to translate words into mathematical expressions. And secondly, we explained how you pick which equation to use in order to solve a problem. Basically, you just try out different ones and see which one actually can take you from the unknown to take you from what you know to what you need to find out. Second example, I like to use this example to demonstrate 2 problem-solving strategies. Number 1, how do you determine the type of a motion? Secondly, it's called chunking. Chunking is breaking a complicated problem into smaller pieces. That's readily solvable. Okay, so read, and read. One object is moving at 65 meters per second for 30 seconds. Okay, so during that 30 seconds, it moves at 65 meters per second. It's not going up, it's not going down. During the entire 30 seconds, it's a constant 65 meters per second. So that's a constant velocity. So that's how I determine the type of motion, by reading and analyzing and try to find the meaning of it. And then 40 meters per second for 15 seconds. So during that 15 seconds, it remains at 40 meters per second, not higher, not lower. They're constant. So that's a second piece of motion. If I break the motion down into 2 pieces, each one is a motion with constant velocity. Overall, it's a motion in 1 dimension. It's not a constant velocity or constant acceleration. So we can use the definition for general 1-dimensional motion. For general 1-dimensional motion, the average velocity is displacement over time. Total displacement over total time. So if we plug in the numbers, that's the result we find out. In summary, we learned 2 things from here. Number 1, how to determine the type of motion so that we can figure out what equations to use. And secondly, how to chunk, how to break down a complicated problems into steps so that in each step we're solving a simple problem that we know exactly how to solve. Okay, the third example. In this example, I'm going to demonstrate 2 things. First, still how to determine a type of a motion. And secondly, this is called a problem-solving strategy called reframe. So first you read the problems. And another thing here is a good way to remind you, if a unit does not appear to be an SI base unit, you want to convert the unit immediately in step 1 so that you're going to use the SI base unit for solving the problem, which is safe. Okay, so I read it 3 times and I figure out the car is traveling at 40 meters per hour. So convert it immediately. Saw a cat 10 meters ahead, not moving. That means the cat's position is a constant, it's fixed. If the car may decelerate at this, so we know that's the acceleration, is the car safe? Okay, so first of all, how do I know it's a motion with constant acceleration? Because decelerating at a constant number, right? So the 3.5 meters per second is now going up, is now going down. During the entire braking process, it's the same acceleration. That's why we use a constant acceleration. Okay, so that's asking us, is the cat safe? Okay, do you remember the law of cat safe, or the cat safe law, or the safe cat law? I'm just kidding. Like, we never learned that law in this class. I don't know if there's any class that teaches you a safe cat law, or cat safe law, or law of safe cat. Okay, so what do we do if nobody has ever taught us how to determine if a cat is safe? So then you have to create, you create your own way to solve the problem. So that's what we call reframing. Reframing is to ask a question. By solving that question, that can help you answer the question here. So the question I'm asking here is, what's the displacement of the car during the braking process? If it's more than 10, then the cat will not be safe. It's less than 10, the cat is safe here. So let me see. The equation to use is this, because that has the 3 known quantities and 1 unknown. And if I plug in the numbers, I can calculate that the displacement is 45.6 meters. Well, there's a little typo here, excuse me, I'm sorry, I apologize. It's 45.6 meters, much larger than 10 meters per second. In conclusion, the cat is not safe. So in summary, we learned a few things. Number 1, if the unit is not SI base unit, you want to convert it in step 1. Number 2, how do you determine the type of motion? Number 3, reframing. That is to ask a question which can bring you to answer the question. Okay, last thing but not the least is everybody can make mistake. I can make a mistake. If I make a mistake, you catch my mistake and you give me a feedback. You earn an extra credit for that. I'll tell you how to apply the extra credit. So that's a class rule. Whenever you discover a mistake, I find, I'm not embarrassed. I'm extremely happy and I'm proud of you guys. I think you are, you're gonna get empowered in this class. When you solve problems better than I do, I'm proud of you. I think that's the best teacher can train students who do much better job than the teacher herself. So go ahead, and I welcome you to give me lots of feedbacks. In summary, we talked about one-dimensional motion concepts, including position, displacement, velocity, and acceleration. You need to know what they mean, the symbols, the units, and also the symbols for the units. Then we reviewed 2 types of motions we call models. These are the simplified types of motions. One is with constant velocity, another is with constant acceleration. And it matters to use the correct model. And please go back and review the problem-solving strategies. These are representative strategies we use to solve different problems.